So in this video, we're going to learn about piecewise defined functions. This should be a review for you, but it's also been a while, and you probably didn't touch on this too much actually in Algebra 1. All right, so in this example, Alani has a summer lifeguard job. She makes $8 an hour. So as you're writing your notes for this one, if you will call this example 1, and you can title it Modeling with a Piecewise Defined Function. And then we're just going to make some bullet points. So what I underline, I would write as bullet points. She makes $8 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times, let's go back. More than 40 hours, she makes $12 an hour. This 1.5 times, I don't know if you have gotten to a job that this applies to yet, probably not, but they call this time and a half, and that means that you get paid like extra bonus for working more than 40 hours. Okay, so how could you make a graph to write a function that shows her pay each week? So they've made a table of values. I'm going to say that that's not necessarily the easiest way, and we'll talk about how to create these, but really what I want to do in this example is just show you what this looks like. So notice I'm going to zoom in on this graph, and underneath where you have your bullet points written, if you will draw this graph for yourself, and it doesn't have to be super specific. If it were me, I would make a note of these points at 0, 0. And then if she's $8 an hour for 40 hours, 8 times 40 is going to tell me that at that moment she's making $320. So that's this point right here, is 40, 320. That means if she works exactly 40 hours, she's going to make $320. Now notice that if she works more than that, so when we switch to this green section, if she works more than that, the rate changes because now she's not making $8 an hour anymore, she's making $12 an hour. So that segment is going to begin to get steeper. So to figure that out, you would just then add 12 from that point forward. All right, so what we want to do is talk about how do these functions look? How can we write this instead of having to write words or an explanation, but can we write a function, an equation all in one place? So what these look like would be something like P of X, and I'll actually use different variables, P of H. All right, the P would stand for pay and H would stand for hours, equals, and they use these curly brackets. There are 2 sections here, so I'm going to name 2 equations. And then I'm going to specify that these happen in certain zones or certain domains. All right, so piecewise is set up, there's like the equation, and then there's the domain that it happens. So the first equation is she makes $8 an hour, so that would be 8H. That's really simple. This occurs when she works between 0 and 40 hours. So if you remember how we just did our domains, this domain is between 0 and 40. Okay, so now, and I probably should have done that in red. Let's highlight that. This is our red section. All right, so now we're going to talk about the green section. And it would be really nice if we could just make it say 12x, but we can't because this doesn't start at 0 anymore. This is starting over here at this point, 40, 320. So as I go to write this function, it is going to be 12 for the rate, but I'm going to use my transformations. I pushed this over 40 to the right. Remember, inside's opposite, so it's going to be h minus 40. Then I pushed it up 320, so it's going to be plus 320. That's my equation. All right. Now the domain for this is going to go from, at this time, this only applies after she has worked 40 hours. So the domain is going to be when x is greater than 40 hours. All right, so this is called a piecewise defined function. So if you haven't yet labeled that, I would write this kind of word beside it. That's what this is, a piecewise defined function. It doesn't necessarily have to have 2 parts. It could have 3 or 4 or 7 if it wanted to. And then we have this question asking us to find a few things. It's asking us to find how much money would she make if she worked for 37 hours, how much money would she make if she worked for 43 hours. You can do that either by looking at the graph or by looking at the equation. And the big part that I want for you to note here, because I think you know how to find this, so I don't want to talk too much longer about this, but this 37, this is in the first segment because that's less than 40 hours. The 43 is in the second segment because that would be when she's working more than 40 hours. So I would like for you to pause the video real quick and see what you can get for these two values. So a quick explanation, I got these values by doing, the first one would have been 37 times 8 because 37 is less than 40 hours. So if I just multiply that by the rate of $8 an hour, that's going to give me $296. I can use the equation that I wrote for this second one, but actually, if I'm being honest, I did not. I just used kind of common sense. Over the first 40 hours, she's getting paid $8 an hour. That's an 8. But for the next 3 hours, because that's over, she's getting that extra pay. So at that rate, she's getting paid $12 an hour. So that would ended up being 320 plus 36, which is where I got the final total of 356. Unfortunately, you can't read these from the graph as well on this one because the graph is not super specific in how it's laid out. In this example, I want to show you a special type of a piecewise function called a step function. All right, so this example talks about the shipping cost of items based on their weight. So weight is what it's based on, so notice that is on my x-axis, and shipping cost is my output, so that's going to be on my y-axis. So for this example, you should be copying down this table of values, and we're going to create this graph. All right, so this says from 0 to 2 pounds. So I'm going to go ahead and mark off my axis. 1, 2, 3, 4, 5, 6, 7, 8. So from 0 to 2 pounds, the cost of the item is going to be $5. All right, I'm going to count by fives over here. 5, 10, 15, 20. On the bottom, I'm counting by ones. So from 0 to 2, it is $5. That is just a flat rate. Right? So this is actually going to end up being just a flat segment. Notice the 2 there. If I zoom in, you can see the 2 has an equal to sign. So I'm going to put a solid dot right there. But the 0 does not, so it should actually be an open section. All right, the next segment says from 2 to 4 pounds, the cost jumps to $8. So notice there's no connection here at 2 pounds. It's going to simply jump all the way to $8 with an open circle. And that price is going to continue until you reach a weight of 4 pounds. All right, then at 4 pounds, from 4 to 6, my price is going to jump up to a cost of $11. And again, this jump just instantly happens. And it's going to connect over to 6 pounds and be a closed circle again. And then my last segment goes from 6 to 8. This cost now is at $14, an open circle and closed. All right, what I would do for this in my notes is you should label that this is a cost of $5. It's really hard for me to write on this, so hopefully yours is neater than mine. A cost of $8, a cost of $11, and a cost of $14. Now that we have this written out, you should see why it is they call these step functions, because this looks like a set of stair steps. I also want you to notice the reason that they don't that these are open and closed is because if you had 2 closed dots on top of each other, this would not be a function. So it is always important that you have a closed and an open circle above that. You can't have 2 closed dots right on top of one another. Notice that happens every time we jump from one to another. All right, these are called step functions. If we were to write the piecewise function for this as a function, it's almost kind of shown in this table here. This would have 4 pieces to it, which means we would have 4 domains. The first piece would be a flat rate of 5. So this is just a constant function. so we can call this f of x if we want to, would be 5, where the domain is between 0 and 2. Then it would be a cost of 8 from 2 to 4, 11 and 14, so on and so forth. So I would get this copied in your notes so that you can see the piecewise format for this function. And then the last thing that I want for you to note is that step functions can also be written out as just kind of like how absolute functions can be written out on their own, so can step functions. The format for a step function looks like this. It's got like a bracket, a bottom bracket, or sometimes they look like actual brackets or with a double line. All right, that is the notation for step functions. So the goal for your video today was really just to get an understanding of what piecewise functions are, what they look like, and how they're related to their equations and how they're set up. We are going to spend a lot of time tomorrow in class working on how to interpret them, how to graph them, how to read them, and evaluate them. So make sure you are here tomorrow with notes ready to go.